turning points in calculus. Still, this is a continuation of the derivative, differentiating. It's just a continuation or an application of it. So what are turning points? So one important practical use of differentiation is to determine precisely the position of any turning points of the curve defined by a given function. So the turning points, that is points of local minima and maxima, are of particular interest in many business applications because they represent points of minimum cost or maximum points of revenue. These points are points of zero slope or gradient. So certain functions have two or more turning points, so it's necessary to test whether the calculated turning point is a maxima or a minimum value. This is usually done by finding the second derivative. If the second derivative is negative, the turning point is maximum. Very important. And if it is positive, the turning point is minimum. Very important for you to find out. So what are we saying when we are talking about turning points? So again, I'm going to assume I have a curve right here, and before that I just have a graph like that. So in this graph I have a curve like this, okay, and now we have one turning point on this curve. Okay, so why do we have a turning point? Because the curve is changing direction. So where do we have it? We have it at this point. At that point we have a turning point. Why? The curve is changing direction now to a negative side. This is negative, this is positive. So when it was climbing up here, this was a positive side. Now when you get to this point, this is a turning point. The curve changes direction to the negative. That's why we are calling it a turning point. Okay, so if you had another curve here, and this curve looks like this, you can see now we have again a turning point, and the turning point is at this point right there. Okay, so here we have our turning point again. Okay, so now one thing that you should note carefully is that at the turning point the gradient is 0. So whether it's a negative or it's positive, the gradient at the turning point or at maximum, so this is a maximum point, maximum. Why are we saying it's a maximum? Because on this line represented with blue, we don't have any other point that is higher than this point right here. Okay, than this point. This is the highest place. That's why I was saying it's the maximum of this blue curve here. Now on this other side, this is the maximum, the minimum point. Okay, minimum. Why? Because this is the lowest point of this curve right here. So this is the minimum, and this other one is the maximum. So when you hear about minimum, maximum, maxima or minima, sometimes you hear minima and maxima. We are referring to this point. So when the curve looks like this, this is a maximum point on top. When it looks like this, this is a minimum point at the bottom, as you can see there. Right, now having said that, now let's look at now what we are saying about the derivatives. So I'm going to just wrap this a minute, and we are saying that this point here has a 0 gradient right here. So if I was to drive a car at the top at this maximum point, the car would be straight, meaning there is no, the gradient is 0. There is no gradient. In fact, there is no slope. It's flat. The gradient is 0. The same point even here. If I draw a line here, this point is 0 slope. That means if there was a car here, it would actually be flat. Okay, so the gradient at maxima and minima is 0. So again, I'm going to write this. So the gradient, remember we said the gradient the gradient or the slope at maxima. So at maxima or minima is always equal to 0. So at the turning point, the gradient is 0. I hope that is well gotten. So having said that, allow me to just remove this to get space to work. So now, assuming we have y is equals to 3x cubed minus 2x squared minus 5x. So let's assume this is our curve, and you're told get the point where the gradient is 0, or find the value of x where the gradient is 0. Okay, so what do you do? So how do you get the gradient? The first thing you need to ask yourself, how do you get the gradient of a point on a curve? So we want the gradient at this point. Remember we said at this point the gradient is 0. So what we actually want to know is at that point, what is the gradient, what is the value of x? So remember this is x, this is y. So we want to know what point is this. Alright, so how do we get that? We get that by first differentiating. So we need to differentiate our function. So if we differentiate our function, remember we said differentiating is getting a slope. So dy by dx is equals to, so we have done this in our previous class, so this would be 9x squared minus 4x minus 5. So that is dy by dx. That means if you differentiate this function, you're actually going to get this one. So what do you do next? The next thing you actually do is you equate now this function here to 0 for you to get x. So you are going to have 9x squared minus 4x minus 5 is equals to 0. Okay, so now you're supposed to solve this equation for you to get the value of x. Okay, so when you solve this equation, you'll actually get the value of x where the gradient is 0. Okay, now having said that, let me give another example. So assuming you have an equation like y is equals to 3x squared minus 4x plus 5, and you're told get the value of x at maxima or at minima. So what is the value of x at the maximum point or at the minimum point, or where the gradient is 0? Again, what do? You do dy by dx first so that you get the gradient. So this will be 6x, I hope you can follow me because I'm not repeating, minus 4. So that's your dy by dx. Okay, so having found your dy by dx, the next thing is equate this function that you've gotten out of differentiating to 0. So this will be 6x minus 4 is equals to 0. So of course you take this 4 to this other side, that you have 6x is equals to 4. So divide by 6, divide by 6, so that now you get x is equals to 2 over 3 or 0.67. So the value of x where the gradient is 0 is 0.67. Good. Now having done that, the next thing they will be asked to find is your curve a maxima or a minima? Because remember, when you have a function like this one, you may not know whether the function is a maxima or a minima curve. So again, maxima looks like this, minima looks like this. So you may not know this one is a maxima curve or a minima curve. But there is a way that you can actually do that, and these are the steps in identifying the turning points. So turning points essentially mean the maximum point or the minimum point. So how do you get the turning point? First, the first thing you do is obtain dy by dx, which is actually the gradient or differentiate. So you differentiate this function. That's the first step, as you can see right here. So first step, dy by dx, which again is equals to 6x minus 4. So that's your dy by dx. What is the next thing? Find the value, find the x value for which dy by dx, that one, is equals to 0. And we had gotten that as 2 over 3. So the value of x for which dy dx is 0 is 2 over 3. Okay, then the third step, now in the third step, remember you have already calculated this one before. Then the next thing is evaluate the second derivative at each x value found in step 2 and use the following results. Now there is a concept that we have not done before, which is called the second derivative. So how do you get the second derivative? You essentially get the second derivative by differentiating the equation a second time. So what will you be differentiating? You'll be differentiating what you have already differentiated. Your first, remember this is your first derivative. Okay, you have differentiated this function one time. So this is the first derivative. And now you want now to differentiate now this one the second time now. So remember now, what are you differentiating the second time? This function that you have already differentiated. Okay, so now you're going, now the second derivative is denoted by d squared y by dx squared. So that's the denotation for the second derivative. This one was the first derivative. So now differentiate now this one here. So what will you get? You're going to get 6 as your second derivative, having differentiated this function here. Okay, so now you've gotten 6. So remember we are in step 3 and we are told if the second derivative, so you have done evaluate the second derivative at each x value found in step 2. So step 2, what did we do? The value of x, 0 there. So now what is the value of x, okay, where we have the second derivative? Remember you have calculated the second derivative to be 6, sorry. So it's positive, then the second derivative, that means we have a what? A minimum point, because this is a positive value. So what if it was negative? If it was negative, then it is a what? A maximum value. That means if we were to draw this curve, in essence it should look like this. If we were to draw this curve, it should be a minimum point. So this should be a minimum point, not a maximum point. Okay, we are going to do still another example for you to get it right. Okay, let's do a second example. So I'm going to have y is equals to 5x squared. I'm actually going here. We have 5x squared minus 6x plus, well, let me just put plus 4. So now you're told, can you determine whether this point is a maxima or a minima? Number 2, also determine the point at which x is, I mean the derivative is 0. Get the value of x, okay, get the value of x where the derivative is 0. So what would you do? the first thing you do again is dy by dx. So dy by dx of that function. So differentiate this 5 times 2, you get 10x, then plus 6, and we are done. So remember, anytime you have a whole number like this and you are differentiating, when you differentiate that, you get 0. So anytime you get a whole number and you differentiate a whole number, you get 0. So why do you get 0? Maybe I may answer that before delving into that one. If you see a whole number, as far as you're dealing with calculus, just know there is an x raised to power 0 right next to it. Okay, there's an x raised to power 0. And remember we said x raised to power 0 is what? Is 1. So 4 times 1 is still 4. That's why you may not see x to power 0 next to 4, but know at the back of your mind there is an x to power 0 next to 4. Okay, so having done that, if you differentiate this function, remember how we were differentiating, you get 4x, okay, to power 0. If you differentiate this one, 0 times 4 is 0. Okay, so 0, then x 0 minus 1. So what is 0 times x raised to power negative 1? It's of course 0. So that's what I'm saying. Any whole number, when you differentiate it, you always get a 0 as the derivative. So that's why we didn't add here plus 0. So it's not necessary. So when we differentiate this function, you get 10x plus 6. So now let's get now the second derivative for us to know whether this curve is a maxima or a minima. So before doing that, we need to get the value of x. Remember, the value of x where the gradient is 0. So you're going, of course, to equate this to 0. So you'll have 10x plus 6 is equals to 0. So take this 6 to this side. So you'll have 10x is equals to 6 minus 6 actually, because when you take it to this other side, you get a minus. So divide by 10, divide by 10. So that you get x is equals to negative 6 over 10, which is equals to negative 3 over 5. So that's the value of x at the maximum or minimum point. Okay, now having gotten that, the next thing you do is now get the second derivative of the function. So to get a second derivative, you denote it by d squared y by dx squared is given by, so you're going now to differentiate this function here. So of course when you differentiate this, you're going to get 10. Okay, so after getting 10, what is 10? Is it a positive value or a negative value? Again, this is a positive value, and because it's a positive value, then it's a minima. It's a minimum curve. Remember this, the second derivative is positive. If the second derivative is positive, then we have a minimum. So because 10 is positive, then this curve is a minimum or has a minimum point. And minimum point, remember we are saying it looks like this. So this point here. Good. So hoping that is understood. So if you have any question concerning this, you can write it down there on the chat and I'll be able to answer it again. So we have done all now the maxima and the minima, and I've demonstrated to you. So now let me give a question. Now consider this function. There's a good function right here. So you're told now, is it a maxima or a minima curve? Okay, so again you follow those steps right there. So do you do y is equals to x squared minus 8x plus 60. So the first thing again, get dy by d. So dy by dx is equals to 2x then minus 8. So this becomes your first derivative. So your first derivative is there. Now let's get our second derivative first. So d squared y by dx squared. Now you differentiate now this equation, so you're going actually to get 2. Okay, you get 2. So that means when you get 2, of course that's a minima. Remember, when the value is positive, you have a minima. Now when you, what if you asked what is the point? What is the point? What is the value of x where the slope is 0? So what would you do? This is what you equate to 0. Okay, so you're going to have 2x minus 8 is equals to 0. Take this to the other side. So 2x is equals to 8. Divide by 2, divide by 2. So you get 4. So x is equals to 4. So at x is equals to 4 is where our slope is equals to 0. Okay, so you have to get that this is the one that you equate to 0, not this one. Please be careful. So dy by dx is what you equate to 0 to get the slope where the slope is 0. So what do I mean? So the interpretation of this is that if you have a curve like this, so if you do this, now it's actually supposed to be a minimum. Remember, it's a minimum. So if you have this, now this point right here, the value of this point, if you come down to the x-axis, this is 4. Right, this one. Okay, so remember we said at this point the gradient is 0. It is flat. Okay, so that's how to interpret that. But if you're just working with different kinds of values, say you are working with r is equals to 3q squared minus 4q plus 5. So would you be able to get the derivative of this function? So how do you get the derivative of this function? Again, it's the same, just that we have changed our signs, but now this is r and this is q. So now to get the derivative, now you'll do dr by dq. So dr by dq, which is the first derivative, or differentiate. So 3 times 2 you get 6. So 6q, 2 minus 1 is still 1. So then minus 4. So that's your derivative for that function. So to get the value of q, okay, where the gradient is 0, what do? You equate this function to 0. So 6q minus 4 is equals to 0. So take this to this other side. So 6q is equals to 4. So divide by 6, divide by 6. So you get 2 over 3. So the value of q, the value of q, where q or the slope is 0 or the gradient is 0 is 2 over 3. So before ending this lesson, I felt it was important for me to mention this so that you know, why do I even need a turning point? Why is it important? Okay, so I decided to have this. So a turning point is important, especially in the business perspective, because assuming you have 2 curves here, like this. So a revenue curve, now let me put this as a revenue curve, and this is a cost curve. Okay, now in terms of business, we all know what revenue is. Revenue is also sales. Okay, and we also know what cost is. Now, assuming you have a revenue curve and a cost curve, remember, now we're in business. So a revenue curve normally have a maximum, and a cost curve normally has a minimum. So what does that imply? This implies that a revenue curve, you need to, in a revenue, or when you're making revenue, you need to maximize the revenue. That means you need to make the highest revenue that you can get. But when you go to cost, you need to cut costs as much as you can. So you need to minimize your revenue. That's why this is a minima curve, and this is a maxima. Why? Because you maximize sales, but you want to minimize the cost. That means all revenue functions should be positive curves or maximum curves. Let's call them maximum. Why? Because they have a maximum point. But all cost functions should have, or curves should have, a minimum point. Meaning you want to minimize the cost and you want to maximize the revenue. So a question now, having given that, how do you think a profit curve should look like? A second for you to think. How should they look like? So let's say that you've gotten it right. A profit function should, of course, have a maximum. Why should it have a maximum? Because you want to maximize the profit. So a profit function should have a maximum point. Should have a maximum point. Why? You want to maximize on the profit. So revenue maximizing, profit maximizing, but cost you minimize. Profit, revenue you maximize, profit you maximize, cost you minimize. So I hope you've gotten that, because we are going to be using this in our next class, because we're going to be doing application of differentiation or differential calculus in business. See you then.